help there, reach out to me. But let's now think about the topic then, and we're here to talk about data engineering. So let's now address the main problem here in the title. Let's deal with some ambiguity that we might otherwise have. And I've said in this session an introduction to Azure Data Factory and integration pipelines. And it's that integration pipelines part that I just wanted to focus on firstly, because what Microsoft have of course now done within Azure as services have become more common, and we've got other ways of doing things that you would say that there's more than one way to skin the cat, to choose an old English term, which is very much true. So what we can say is that to maybe refine this title, I'm going to say to you an introduction to Azure integration pipelines. And what we mean by that then is that something that is very resource agnostic in terms of orchestration. So we could very much be referring to pipelines that exist within our data factory resource, or we could be referring to pipelines that exist within our Synapse Analytics workspace. So we've got that flexibility now, and what we could probably say very generally is that for the things I tell you about, we could be talking about one or the other. Synapse and Data Factory are very interchangeable in terms of the content that I'm about to show you. Okay. So if you like the slides that I'm about to show you, then you're very welcome to go and grab a PDF of them. They're already available in my community events repository on GitHub. There's subfolders in there for the event, the location. I think I just called this one Robert Walters. So go and grab that PDF, and you can maybe look ahead to some of the visuals if you like. But I'll share this at the end as well. Now, the other thing I've done is, because this is an introductory session, it's always quite hard, or I find it quite hard to do an introduction. Doing an introduction is harder than doing a deep dive. That's mainly because within these services now, there is so much that I could talk to you about. I can literally, and have done, spent an entire day doing full day training courses on Data Factory. So to try and condense things down into an hour is a bit of a challenge. So what I've done is, as you'll see as we go through the slides, I've kind of tried to include some links and to some blog posts, some other places where if you want to go deeper into a particular topic that I've introduced, you can do so via those links. So look out for those as we go through. So our agenda, and say this is the hard part, what I've tried to do is this all-round view of Data Factory is what I want to deliver for you today. Starting off with the very simple of the whats and the whys. Then we'll look at some common components and some fundamentals, stuff like source control and deployments and logging and monitoring, to say, try and give you that all-round view of what Data Factory is as a resource. So let's dive in, because we've got a lot to get through. And let's start with the very simple, the what is it and the why use it. So as a quick history lesson, Data Factory as a resource, it's actually been around now since July of 2016, when V1 first landed for us within Azure. And because I'm old, I've been using Data Factory for that amount of time. It's for the first time I think I can now say I have 5 years experience working with Azure Data Factory. As you think about how new some of this technology is within Azure, to say I've got 5 years experience in it feels like quite a long time. I think these days you're now an expert in something if you've used it for about 2 or 3 months, it would seem. So I think 5 years is good going. And during that time, Data Factory has gone from strength to strength, and the resources got very rich to become almost a crucial element of any data platform delivery, particularly when it comes to the control flows and the data flows that we might want to create for a modern data warehouse, an analytics solution, or anything where you want to get your data from A to B to C. Anyway, quick history lesson. It's been around for a while and it has matured. So 5 years of maturity is pretty good going now for this resource. But what is it? Well, if we ask that question of Microsoft, and I do this a lot to see what the marketing people ultimately tell us what Azure Data Factory is, we get some medium narrative, some narrative that doesn't quite hit the spot for technical people like ourselves, but some narrative that's a pretty good start. And what we'll learn from this web page, if you go to visit it, is an overuse of the word integration. Integration, hybrid data integration, and all flavors of the same. Okay, so Data Factory is about integration, I think we can glean to begin with. But yes, we're technical people, so let's go deeper. That's the Microsoft version. Let me give you my version, and hopefully I can be a lot more informative. So, as I've said, we have very general, very simplified, some data, we want to get it from A to B to C. In this case, some files, maybe into some storage and into possibly a database of some sorts. And what we'll start by saying is that Data Factory is, as I'm going to describe it, the orchestrator. We've got our little guy there conducting, and Data Factory is there to schedule, to manage, to give us monitoring capabilities over that data process from end to end. Now, it is the orchestrator, so what I like to think of is that Data Factory doesn't really do any of the work itself. It's quite a bossy resource in that sense. It tells these other things to go and do this work, which we wrap up in a pipeline. So to really sort of follow that through, I like to think of my wife as a data factory. She's very bossy, and then she tells me what to do. So I'm one of the services that Data Factory invokes that has to go and do the work. This may be true of your household, I have no idea, but just a bit of fun. So let's start with that. Data Factory is our orchestrator. But let's go deeper. Let's go deeper and actually look inside our Data Factory to really inform why this is the case and what we actually need to build to get our Data Factory pipelines running. So we've got this process that I've introduced. What might we actually need to build within Data Factory to make this happen? How do we do this? Well, the first thing we'll need within our Data Factory is something called a link service. And a link service here is a means for Data Factory to connect, to authenticate, to reference the service that it's going to go and interact with. So if we pick on the case of a SQL database, we will have a link service that contains the connection string. It will contain things like how we authenticate, the username, the password, the logical instance where this database lives. And we need those link services as that first point of allowing Data Factory to interact with whatever we're going to build in our later pipelines. So bear that in mind firstly, link services number one. Number two is this idea of a data set. Now, this isn't the data itself, but more a metadata representation, if you like, of what we're going to interact with. And data sets will use those link services to authenticate. So sticking with that SQL example again, we might have a data set that references a particular schema, a particular table within our database. The data set will have metadata information about the attributes, the data types. If it was a file in our storage, that file path, the file extension, all these things that we might want to use and information that becomes important for what we then do with our pipeline. So bear that in mind. Number two are data sets, which can also be very generic as well. Then we have number three, something called an activity. So the activity is the piece of work specific to the service that we want to go and invoke. So if we say we want to call a Databricks notebook, we will have an activity for that. And we bring on that activity, it will have information about the workspace, the path within that workspace, parameters that we want to pass to it. And like our data sets, our activities will authenticate using our link services, number one. Okay. Next up, we have this thing called a pipeline. Now, a pipeline is definitely one of those words that gets overused a lot. And we could say that all of what I've got here on the top of the slide is my data pipeline. Sure, that's fine. But also be aware a pipeline is a component of our data factory. And what those pipelines allow us to do is to group together all of the activities that we want to go and execute. And if you're a fan of SSIS packages, because you're old like I am, then we could maybe draw some comparisons here and think of like a sequence container within our sys package, maybe. But a better comparison is to think of a pipeline within our data factory as like a sys package itself, because we can then have an activity within a pipeline to call another pipeline. So we can chain these pipelines together. So, you know, a reasonable comparison. And for completeness, we can say that a pipeline can contain many activities, up to a maximum of 40 activities, actually. Okay. So those are our first four. And then lastly, number 5 is this idea of a trigger. So a trigger will tell our pipelines when we want them to run. And we attach those triggers to one pipeline or to many. We can call them manually or programmatically via a .NET SDK or via PowerShell if we wish. We can schedule them, which is very much more of an iterative thing that we're perhaps used to. If you think about our SQL Server agent, we attach a schedule to our agent jobs. We attach a scheduled trigger to our pipelines in that sense. We have this idea of a tumbling window, which is very helpful when dealing with time series data. You define a timeline, then you define time slices that will execute at a given point with a given set of parameters, with a date, start and end sort of boundary for that tumbling window, which can be helpful, which can be preferable over a schedule, particularly if you're working with like accounting data maybe. We also have the ability to subscribe to file events within our blob storage. So if we look at a file creation event or a file deletion event, Data Factory can subscribe to that using event grid underneath, and it will cause an execution of our pipeline in that way. So triggers number 5, a means of executing our pipelines. So those 5 components that we have within our data factory, they all, as you've probably gathered, are defined using JSON. And our little conductor man, JSON is his hymn sheet to then go and orchestrate this process, this set of data pipelines of things that we want to do. So those are the components of our data factory. What I want to now do is I want to introduce you to some common activities. And what I'm going to say is that I'm going to use SQL to describe everything. I'm going to say that these are my favorites, my top 5 activities, or the activities that I would almost always use in every data factory instance and a lot of the pipelines that I might implement for my customers. So really just to kind of give you a flavor of what's going in here and what we can actually do with data factory. So let's, tidy up the icons, let's be explicit and say, okay, we've got these activities within our pipelines. And the first one I want to introduce you to, perhaps the most common, is the copy activity. And the copy activity will take a data set as the source and a data set as the sink or destination. And a copy activity is very helpful. So it is very much, as it says on the tin, about copying our data. It is not about data transformation. It does have some capability to inspect the data set we're working with. It can understand the schema. It can do mappings and things for us and deal with schema drift. It can also do transactional level error handling if you've got a very large copy running, say, across maybe a flaky network connection. It can deal with that and do restarts. It will also do auto scaling for you if you've got a large amount of data that you're copying. So a very useful activity, certainly the sort of thing I would use to say get my source data from a system, maybe on premises or wherever it may live, and land it into my cloud environment in a data lake, a raw storage area or something like that. So that's our first one, my favorite, a copy activity. The next activity to introduce you to is what's called a lookup activity. Now, this is very much still at the control flow level. This is nothing to do with, say, looking up a surrogate key value when loading a data warehouse. So not a lookup in that sense where we're doing a join of data sets, but a lookup will take a data set in, and that could be something like a SQL table where we provide a set of metadata values that we then want to use as part of some other downstream pipeline or process. And what we'll get is when that lookup has occurred, that select statement on the left then becomes a JSON array on the right hand side and an output that we can then work with as part of other things. So with that in mind, let me introduce my third one, the for each activity. So the for each activity wants an array, it wants an input, and the obvious choice there would be a lookup activity. We look up some data set from a SQL table, we use that array as part of what we want to iterate over in our for each activity. And within our for each, we then define a set of child things that are going to happen. Maybe a copy, maybe a function call, and we use that item syntax to define that iteration that we're working with. But this idea of looping, is nothing new. That where the for each activity becomes special is using its default behavior. Now, you might think that, this is very much a sequential thing that can occur. And yes, you can configure that if you wish. But by default, what the for each activity will do is take in that array and it will actually scale out. It will actually parallelize the process that's going to then be ran. So if you have, say, 10 items in your array that you're going to iterate over, it will spawn 10 parallel threads and it will run all of those iterations in parallel. So as far as an activity goes, it is really versatile and really nice to get that scalability within Azure if you actually want to run things in parallel. It's a very nice way of doing it. By default, it will allow 20 parallel threads, a maximum if you set it up to 50 parallel executions, given whatever your input is. So definitely a favorite there, the for each activity. Next up is the execute pipeline activity. So as I've already talked about, you might want to chain your pipelines together, and you might want to then create what I would call a hierarchy or a generational set of control with your pipelines in your data factory. And there's a blog post where I talk about that in a bit more depth if you like, but definitely using the execute pipeline activity to even have some boilerplate code in there and maybe some utility pipelines is an advantage. And then finally, number 5, my fifth favorite, the Azure function activity. This was, I think, as far as activities go, quite a new one that Microsoft made a first-class citizen within Data Factory. And before we might hit our functions with a web or a webhook activity, now we have a link service that means we can authenticate to the functions app via a link service connection. We can then work with that function app. And if we're doing like a HTTP trigger of the function, we have our usual verbs to get, post, and put. And if this was me, I would develop my function app using C# and probably .NET Core. And we might then use it to extend our data factory and do some other stuff. Maybe process our analysis services instance, whatever you like. But functions definitely a very flexible and an easy way to extend your data factory. Now, those are my top 5. I kind of felt compelled to include one more, and that is a custom activity. So when we talk about extensibility of data factory, we can think about custom activities as well. Now, I'm not going to go through all of what a custom activity does and is, but in essence, it will allow you to write some custom code that will execute on an Azure batch service, and then Data Factory can call and interact and do some other stuff if you need it to. Now, the batch service will give you that scale out capability over its compute nodes within what it calls a compute pool. I've included it in this slide deck as kind of another one of those areas where if you want to go deeper, there's a blog post link there to look at what else you could do with a custom activity which might appeal to your solution. Just to deal with a question in the chat, can Python be used or only C# and .NET Core? For a functions app, yes, absolutely, Python can be used. I think the only limitation though is that when you create a function app with Python, you're forced into using a Linux host at the moment in the app service plan. So yes, Python supported, but you might need a Windows host for other reasons. Certainly with customers I've encountered, they're not Linux fans just yet, so they restrict what sort of host types you can use for things. So I don't think Python is support on a Windows host for a function app is the thing I'm calling out there. But yeah, use whatever you like. And then similarly with custom activities as well. So there we have it. Those are my 5 favorite activities and a bonus 6th one as well. So let's keep the pace going, because I say there is a lot that I want to introduce you to here. And the next one is about execution dependencies, which I didn't want to include, but I see this mistake so often that I felt compelled to include it. And that is that if we have a pipeline and we have some activities, in my case, I'm getting some values, we can, from that, like what we're perhaps used to with our sys packages, we can have a path that says on success, on fail, on completion, or on skip, do the next thing, which is fine as expected. A common pattern may be that on failure, we want to go to, say, our error handler, which could be a child pipeline or a utility pipeline that we've got in here. Fine. On success, we might want to do some other stuff. In my case, maybe with a Databricks activity. Now, what I see go wrong, and the point I'm making is that I will then see somebody that says, okay, well, when my functions get value fails, go to the error handler. When my do stuff activity fails, go to the error handler. And then they carry on and they build things up like this. Now, the reason this is wrong is because in a logic sense, what Data Factory does is it's testing in an AND situation. So that error handler is only going to actually get hit if the first activity fails and the second activity fails and the third activity fails, which, given our success path, is ultimately an impossible outcome. So that's never going to happen. So don't fall into that trap of your error handler here is never going to get executed because this is a test and the test is and. The correct way, of course, to engineer that is to use that error handler, but have it as separate execute pipeline activities. And then the test becomes an or scenario. So if this fails, or that fails, or that fails. And that pattern, of course, will work. So maybe if that seems obvious, but I see that go wrong far too often when developers, they just haven't used Data Factory before. So definitely a good lesson to introduce. Great, good pace. Next up, let's think about integration runtimes. Now, I said to you in the beginning that Data Factory is quite a bossy service. It doesn't really do any of the work itself, and that's true. But it does still require an element of compute when it is doing its orchestration, or maybe it's copying, because it has to have something to actually perform that copy activity for you. So in that context, integration runtimes, I'm going to introduce them to you as the compute that Data Factory uses for whatever activities and pipelines we create. Now, I appear to have failed on part of the animation there, but hey ho. So what is an integration runtime then? And what I'll do is I'll say to you that Data Factory actually, it's not just one resource, it's 2. We have our little conductor guy, the orchestrator, and we have the runtime, the compute. Now, this becomes important because what we can actually do within Data Factory is that we can say our orchestrator, our little guy, that part of our Data Factory is fixed to a specific Azure region where you deploy your Data Factory, whichever one that may be. Now, the fun part is that that runtime, that integration runtime and that compute, that can be really wherever you want. That can be flexible to a given Azure region. Now, by default, you will get an auto-resolving Azure integration runtime. And to sort of elaborate on that scenario, you can see on the right of this slide that in this case, I might have my conductor, my orchestrator in, say, the West US data center. But actually, I'm going to instantiate or I'm going to deploy Azure integration runtimes into other Azure regions around the world. And then when you're working with a copy activity, it will use the sink or the destination of that copy to effectively pull data to that target region where that data is going to be landed, as in most cases. So just bear that in mind when we actually think about those integration runtimes. So with that sort of very broad view, let's go deeper, because there are actually 3 or 4 flavors of integration runtime that we can deploy for our data factory. So if I say to you, well, what can an integration runtime do? And I pick on that first one, that Azure integration runtime, which is very much that scenario that I just described to you. So to correct the icons there, this could be an Azure integration runtime that is going to go and do some work for us in our different Azure regions. Now, this could be a requirement for you. If you want to control your data factory from a particular region, but for whatever regulatory requirements or reasons, you know that your data needs to exist within a particular country or boundary or geographical location, then you can fix these IRs to particular regions, and it will mean the compute and the work is done local to where that IR is, not where the orchestrator guy is. And to go one step deeper with that and to kind of offer another sort of jumping off point, it's worth understanding as well that our activities come in 2 different types, internal and external. Now, we could say that an internal activity is what is going to be executed on these integration runtimes here, where you could think of more of as an external activity as something like you're hitting a Databricks instance or a database or a functions app. And there's concurrency limitations attached to those activities as well, which I say is perhaps far deeper than we really want to go in this intro session, which is why there's a link in the top right there to have a look at that. So just bear that in mind that typically it's our Azure IRs responsible for those internal activities. Good. Next up, let's think about then our hosted IRs. So what is this other type of compute that we have within our data factory? So to sort of stick with the same idea and the same picture, we've got our orchestrator guy there with our Azure IR, and we've maybe got a boundary here. We've got some local network, some private place that we want to go to get some data. Now, what we can say with our orchestrator is that he can orchestrate things on the right-hand side here of our cloud boundary, but using this hosted IR, he can then orchestrate the other way as well. So we deploy this self-hosted IR client, which is a software client thing that Microsoft provides you that you download, you install it on a Windows box, you register it with your data factory. And it means then that Data Factory can use that IR as the source for some data that you might want to bring up into the cloud. Very common pattern. And this self-hosted IR, it can interact with SQL instances, it can interact with your file system, it can even handle ODBC drivers if you need that. So, very helpful in terms of getting data from your on-premises or your private location into Azure. And it very much kind of pokes a hole through the firewall, if you like, to do that interaction with Data Factory. It's also quite good in the sense that it can scale out. So you can have secondary nodes here. So a one-to-many between the self-hosted IR nodes and your data factory. You can go the other way and actually have this, this thing that you've deployed on premises linked to multiple data factories. So a linked self-hosted IR is something that you can also do with Data Factory. You cannot currently do that with Synapse integration pipelines, if that was a consideration for you. So just bear that in mind. And to hopefully give you a little more, there are sort of some very complex and advanced patterns that you might want to look at when it comes to integration runtimes and where they sit and how you handle them. If you've got express route in place, you need to have it on the different side of the boundary. So again, I've included this as a point for you to go deeper if you like on this with a blog post I wrote very recently on scaling those integration pipelines globally if you need to. Next up, and for completeness really, I want to call out our SSIS integration runtime, something that you can only do in Data Factory. You don't have this available in Synapse yet, or perhaps ever. So hopefully, as the name suggests, our sysIR is responsible for the execution of SSIS packages. If you've got a lot of packages on premises that you want to migrate into Azure, fine, you can. And you can deploy this IR. You say to it, here's a logical SQL instance, deploy me my SSIS DB, and we can work with it very much like it was if it was an on-prem SQL Server instance running those sys packages. We interact with Data Factory, but as the PaaS wrapper around it. Now, the reason to call it out here and also to introduce you to another anti-pattern I see is we have a run package activity within our pipeline, so that can execute one SSIS package. But there's a problem because that SSIS IR can support actually up to 10 compute nodes, and each node can handle the processing of 10 sys packages. So we can scale out very wide here if we want to. But the problem is that if that compute supports 80 concurrent packages and we've got an activity that will only execute one, how do we engineer it in such a way that we're taking advantage of that max stop, if you like? And what I'll say to you is that if you think about it, handling a parent package with child packages, which could very well already exist, that isn't going to work because it's that parent package that will get an 80th of that compute. You'll have to refactor it so your pipeline becomes the parent in that scenario. So that won't work. I've said to you already that a single pipeline can only have a maximum of 40 activities at once if you wanted to, create all of them in there. So that isn't going to work either. You could, if you wish, use a for each activity and have some metadata that drives that and scale out using the for each activity, but you're still only going to hit a maximum of 50 threads within that for each. So, you understand the problem here that by the very nature and using some of these native tools within Data Factory, we're going to miss out on all of that SSIS compute if we wish to scale out in that way. There are solutions to it. There are ways around it of nesting for each activities and getting very complicated with how you scale out. I haven't written a blog on it yet, but it's kind of on my to-do list. So if this is a problem for you that you're concerned about and you need to overcome this, then reach out to me afterwards and I can talk you through the design pattern to overcome it. Good stuff. Let me have a drink. My mouth's drying up. Let's now change gears again then and let me introduce you to data flows. So when we talked about our components of Data Factory earlier, this is what I showed you. Now, what I'm going to do is I'm going to tidy up the title and I'm going to say to you that these are the control flow components that we have within our Data Factory, okay? And control flow at that higher level, not associated with data transformation yet. But of course, now we introduce the data flow element, we can address that lower level data transformation. So data flows exist within our data factory as an activity that we can bring into our pipeline, and we can then actually start working with that row level, attribute level set of work that we want to do, we may want to do. And just for terminology's sake as well, once upon a time, Data Factory had two data flow types, a mapping and a wrangling data flow. That's since been renamed, and the mapping data flows have just been simplified as data flows. Wrangling has now become Power Query activity. Because this is in essence what it is and what it's doing, as I'll hopefully show you. So let's deal with that first, that data flow, or that mapping data flow, as I think it was called that for at least 2 years. So it's a hard one to change in my mind. But we have our control flow plane, we have our factory, we have our pipeline, and then we bring on this data flow activity. So what a data flow is, for people that like sys packages, as I did, a data flow is this graphical means to do that data transformation work. And we can build this up within our data factory developer canvas. We can bring in our sources, and we can do joins and aggregations and all that stuff that we're probably used to doing with a bit of Python or T-SQL or whatever. But you can now do it in this graphical way via data factory. And what you'll get as the output is something that I believe Microsoft calls their data flow script. And you can look at this within the portal if you wish. Now, the interesting part, or the clever part, is that that data flow script at execution time gets converted, and it gets converted into Scala. And it will then get compiled, and it'll actually get passed to Spark to execute. So if you think about that, and maybe to answer this question a little more explicitly, if I say to you, what is a data flow, certainly within Data Factory, my answer to you would be that it is a graphical, no code or low code data transformation tool that sits as an abstraction over our Apache Spark Analytics ecosystem. Now, for sys developers, I think that's excellent, because it means that we can then transfer those skills very easily to start developing something that's very natural in terms of this interface. But we don't have to then worry about writing, say, the Python, the PySpark, the Scala even. And it means that we get that distributed compute effect via Spark and via this abstraction, and we get a nice graphical interface to work with it. So that is what a data flow is within our data factory. It's that abstraction, which I think is a good thing. So let's just go a little deeper and think about then the inputs and the outputs of our data flow, because they differ slightly. And because we're now constrained by more sort of Scala types and connectors and libraries rather than, say, .NET connectors and libraries, the link services available to us are a little limited at the moment compared to that control flow plane. But what we do get at this level, because we have a Spark cluster and the backing of it, is we've got some data types that we expect, including Excel, which is nice, but then we can interact with things like our Delta Lake, our Hive Metastore, our common data model. So if we have a Delta Lake table, we can interact with it directly using our Data Factory data flows, because we have that Spark implementation there. So helpful, definitely a use case for it when we're doing some of our work as that data transformation level, and a means of actually building that within our data factory. So that differentiation between the control flow and the data flow. Let's now move on and let me just cover off what transformations we have available. So all of the usual suspects in here, just for your reference. The aggregate keys a favorite. You know, pivoting is a good one. Parse and flatten were recently added. But you're thinking, okay, well, what else is there available to do transformation in Azure? And if you were to ask that question, then the answer is a lot of things. There's deliberately a few wrong answers in here as well. Just so it's like, well, you can't use that for data transformation. Yeah, just a bit of fun. But if we then say, well, we've got all these other services, you know, that many ways to skin the cat, as I alluded to earlier. If we say, well, when should we use these integration pipeline transformation activities? Well, the use cases I've seen so far is what I've already said about sys developers wanting to transfer skills. For people that have worked with Power BI, they've developed something locally, they want to take that Power Query out of it and move it into something more enterprise grade and be wrapped up in the pipeline sort of environment. You can do that using that Power Query activity now. If you want to quickly get insight and maybe do some rapid prototyping to load a data warehouse, you can do this through a data flow. It's got the ability to stage and use Polybase to load that SQL pool if you wish, and it can do that very easily, just with a few clicks in that UI. If maybe you're a data scientist, you want to quickly bring some data together, but you don't want to have to write all the Python to do it, then this might be an option for you just to get that sort of data marked in the shape you want fairly easily with the UI before you then go train the model or do something else, maybe. The use cases I haven't seen yet is data flows used for all transformation within a solution. Not for some of the enterprises I've worked with anyway. Maybe for the smaller or medium companies, possibly. And another pattern I've not seen yet, although if you follow a company called Vergence on Twitter, they now, I think, announced that there is a BIML implementation coming for Data Factory that will mean that we can dynamically generate some of this data flow script from metadata, which will then bring us to that sort of level of maturity that we very much had with our sys packages many moons ago. So good, that's data flows kind of covered off now, and yeah, we need to pick up the pace because there's still lots more to tell you. Next, I want to talk about source control and actually deploying our data factory, because hopefully, at some point when we've done that development work, we'll need to do this. And the first thing to call out is that with our Git connected data factory in our development environment, we have kind of both the developer area and, if we wanted, a deployable data factory as well. So a single data factory has this debug service, and it has whatever's been published to it as a resource. But in the context of getting our source code, with our feature branches, our collaboration branches, we have those artifacts there and those components that I talked about that go into building your data factory, which is fine. What you can also do is you can download an ARM template and you get a zip file for this via the UI, which will give you another set of artifacts that you could use if you wish. Then actually, if you think, well, I'm going to look at that publish branch and that publish operation, what Data Factory will do is it will create another branch within that repository called ADF Publish, or I think you can actually customize the name of it now. You can get, lo and behold, a third set of artifacts from your Data Factory in a Git connected scenario. And which one do we use? Or which one should we take forward in the context of our deployment and our continuous delivery? So in case you were guessing, in the pattern I'm going to introduce to you firstly, it will be the one that comes from that publish branch. Well, that's the one that I would use. As you can see, this is exactly as it's named, ARM template for factory. And that's what you might want to take forward. So you need to do that publish and that build operation to get this firstly. So let's now think about it. If we were to use Azure DevOps, we might want to build our artifacts or get that publish. We might want to use some sort of branching strategy like Git flow, possibly. That's what I'm a fan of. But it means that from our dev environment, once we've done that, we get that ARM template, we get that JSON artifact that we can then use and take forward. Then we have a rocket. I'm not sure why releasing is a rocket icon, but I like it. Let's launch the data factory with a rocket. And let's use, say, a release pipeline for this first scenario. Let's have an ARM template deployment task. Let's use some scope variables and things within there, and let's use that to publish our first data factory and maybe trigger it, and we get our test environment. Okay, fine, we could do that. We clone it, we do the same thing for production, Maybe we have some gateways and some approvals, and we can do the same thing again. We get our production data factory. This is fine, this works, this is okay. But what I'll say to you is that this is quite a simple approach. It's more of a wholesale approach. And when you have a massive data factory, do you really want to go and redeploy all of it every time? You might have triggers and things that are already running in there, which means that deploying all of it, stopping those triggers, isn't the best way for you to do it. It does also mean that at deployment time, the only thing you can really customize is those link service connections. The other pipeline parameters, all of the other JSON that goes into that data factory, unless you want to go dissecting that ARM template yourself, there's no real other good way to do it if you use that artifact from the ADF publish branch. So as you can see from my title, I'm introducing this to you as the simple pattern and the simple way to go about it. The more complex way, and this is a bit where we don't have time to go deeper at this point, but the way I tend to deploy Data Factory for my customers is using those artifacts from your feature branch, from your release branch, from your tags commit, however you want to handle your source code repository. But instead of using that ARM template, use those individual artifacts that you will have. You'll have one file per artifact within that repository. Use those to deploy only the part of the data factory that you want. And check out, as I put a link at the bottom here, my colleague Camille's PowerShell module, where you effectively align the PowerShell commandlets to set a pipeline, to set a link service to the artifacts within that code branch, which gives you a lot more granular control. You can be a lot more dynamic with what you want to do and how you deploy your data factory. So that is the pattern that I would use and I would suggest. Use key vault linked variable groups. Use YAML to do this rather than the release pipelines. It gives you a lot more control and flexibility. But a point for you to go and dig deeper, I think. And I tried to summarize some of the key decisions there for that DevOps story and that summary of, what tool you're using, how many environments, what you're going to use as your deployment method, which artifacts you're going to use. So that kind of gives you perhaps opportunity to go and ask more questions and find out more on doing this. Then let's change gears again. Let's now think about monitoring and logging, because in Opera, we can't just develop, throw it over the fence to managed services and say, hey, crack on, there's your data factory, bye for now, which I would love to do, but no, we can't. We're good developers. So what do we need to do for our data factory? And this is now very much true for a lot of Azure resources. You'll see this capability in the portal all over the place. Diagnostic settings is what it's called at the moment. And you go in there for Data Factory or for anything else, and you say, configure diagnostic settings, create me a set of outputs of the telemetry, the logs, the metrics, the whatever that resource can provide for you, and do something with it. Now, the first option is my preference, my favorite. Send that telemetry to Azure Log Analytics, which is a wrapper or a subcomponent of Azure Monitor. And it means that we can then go and build dashboards and create things over and above what we've got within our data factory. The monitoring portal within Data Factory natively is good. It's good for troubleshooting, but it doesn't necessarily give you all of the detail that you might want to see if you've got lots of data factories, or if you're doing, say, some performance monitoring of how long pipelines take to run over the weekend or something like that. So log analytics and getting that telemetry out, I'd say, is a must. You could, if you wish, use Event Hub as well. It's always good fun to have a real-time stream of telemetry to then do something with it. Doing analytics on your analytics platform, it's an option that you've got there as well. You've got that storage account for long-term archiving as well if you need it. But just sticking with that log analytics scenario, you'll then need to write some custo queries over it. And you write those custo queries, you can render them and summarize them as a chart. And what's really great in Azure is that you can take that chart and that output, and you can then actually pin it to a wider dashboard of stuff. So if you've got lots of things in your solution, you can then take a part of it and pin it alongside those other resources and see, alongside at a given point, what was the memory usage on my function app versus the data factory pipeline that was running versus the CPU utilization on my SQL database. So suddenly creating those operational dashboards for your managed services teams, they will love you for it. So go and do that and use that diagnostic settings and telemetry to get this out for Data Factory at least. Other services is optional at this point. Good stuff. How much time we got? 5 minutes or so. Okay, let's wrap up then. Let's have some conclusions because I've talked for an awful lot and I've bombarded you with an awful lot. And I'm sorry it's all theory, but it's an intro session and there is so much to introduce you to here. So let's just come full circle and let me say to you, well, what is Azure Data Factory? And we started, of course, with this very simplistic picture of our orchestrator that sits there above our process. What I now want to do is, and to be a lot more informative, is say, okay, well, it's not just Data Factory, it's our integration pipelines at large, and we can do a lot more in here. This picture now becomes a lot more complex with this appreciation of what I've told you. So to answer it and be a lot more granular, we can say that it is our complete integration tool. So overusing the word integration because the marketing people were right. It is an integration tool that is used and is probably an essential component of our solutions. It gives us that control flow capability, but not just control, but also the ability to scale out as well, which I take advantage of all the time, that for each activity that we can parallelize. We have that data transformation element in there as well, which is then using Spark underneath, which is nice. We can schedule our solutions, our data platform, our data warehouse loading end to end. We could also use it with some other dynamic frameworks and things if you wish to orchestrate all of the stuff, not just in the cloud, but maybe on premises as well via that hosted agent. So that's kind of a more informative answer of what Data Factory is. So what next? Well, I guess for you guys, obviously with me now bombarding you, I'd say the next thing I would encourage is go and check out my blog post on implementing Data Factory best practices, because I've got another set of bullets and things that you can go and look at when you're building your solutions for whoever. This blog post, I think it gets like about 100,000 hits a day now. So there's definitely a lot of content on there, and I know it gets a lot of visibility. And recently, the Microsoft product team asked me to go and update it as well because it was better than their documentation. I added that last bit, but I think it's true. So go and get that, go and have a look at that. And then maybe a last sort of shameless plug as well, I think. But if you want some more sort of practical tips and advice, go and check out this book by my friend and ex-colleague, Dr. Richard Swinbank. He was the author of this. I did the technical review on it. And this book, Azure Data Factory by Example, it will give you a step-by-step guide of actually building some of this stuff for real if you want to go and do that. So I think with 2 minutes to spare then, thank you from me. Thank you very much for listening. I appreciate it was very fast paced and I've been machine gunning your brains with all of this stuff, but there was a lot to pack in there. And but I think this was my summary, my conclusion of what you needed to know about Data Factory as an intro. So thank you.
Brilliant. Well, Paul, that was a lot of information, but hopefully everyone that logged on takes some stuff away from it and carries on improving in the world of Azure. Just so everyone knows, a recording of the session is going to be posted on LinkedIn. If you want to go back and sort of rewrite, re-listen and catch up on a couple of things. I know it was a lot of information to take in. Obviously, whilst you're over there, drop Paul a quick follow on LinkedIn. stay up to date and go and check out his blog as well. Also keep an eye out on the meetup page. We're going to have another guest speaker announced shortly. But yeah, just once again, thank you, Paul. It was a brilliant session, and I hope everybody enjoyed it.
Any questions or any thoughts from anybody? Feel free to come off mute if you wish.
Paul, Anthony speaking.
Hello.
Paul, yeah, thanks very much for that. Yeah, it's sort of first time I've sort of seen Azure Data Factory side of things. Wanted to find out on the monitoring side of things at the end is what do you sort of generally, how do you sort of monitor it? Obviously, you're saying he's using the inbuilt version, can be a bit of a shortfall. Do you sort of take that data out and put it into a sort of Power BI report or into sort of some other means of reporting?
Yeah, did you perhaps miss the diagnostic settings and piping it into log analytics and then writing some custom queries over this to create some dashboards and obviously do some stuff that's a lot more informative? I think that's.
So the dashboards there, are they then sort of just sort of sitting on top of that then as a sort of Power BI sort of some sort of dashboarding within Azure Data Factory then?
Not within Azure Data Factory and not within Power BI. So this is just an Azure portal dashboard. So you take that telemetry out of Data Factory, pipe it into Log Analytics, write a custom query to give you whatever you want to see, and then you can pin that custom query as a chart to your Azure portal dashboard, a bit like something that I've got on the screen.
Cool. Okay, great. Thanks.
No problem. I think we've got a question in the chat. The architect at my company has made a statement that Excel should no longer be used for Power BI prototypes. What is the location that could be used in Azure to house data instead for prototypes? And is it actually a better process to build prototypes? I don't think we should go as far as to say as Excel shouldn't be used. I think if we're creating a prototype, then we would assume it's throwaway at some point here because it's a proof of concept or whatever. So if you're doing a proof of concept, I don't think there's any grounds to say that any tool shouldn't be used. I think we could use anything there. I guess the thing to be mindful of could be cost. If you're prototyping and you're using Azure, you're going to incur costs even at development time. So if you could do something locally for a prototype and that's good enough, then I would probably encourage that to avoid those Azure costs. But no, I don't think there's anything taboo or wrong with using any tool to do a prototype. Would be kind of my thoughts on that.
Brilliant. Well, Paul, I think you've you've obviously helped out everyone a lot. I think everyone's enjoyed that session a lot. So, thank you very much once again. Like I said, everyone go check out Paul's blog, connect with him on LinkedIn, and we'll keep you posted with the next guest speaker.
Yep. Enjoy the rest of the day, everybody. Have a good weekend.